So let's look at some different kinds of pumps. The first would be PDP, or positive displacement pumps. Positive displacement pumps are interesting because they change the volume to force fluid into and out of the pump. You might also hear of these. You might also hear these called geometric pumps. Another interesting thing is they use static effects instead of dynamic effects. So what do I mean? Well, they're just changing the geometry. So it's not a momentum thing that they're doing. It's just a pure geometry change. So all of you are carrying around a positive displacement pump in your chest. Your heart works like is a positive displacement pump. You have muscles. You have chambers inside. An electric current goes through the heart, which causes it to contract. When it contracts, it makes the chambers a lot smaller and squirts the blood through the rest of your system. In fact, it puts a lot of pressure on there. I remember being told once that if you stab somebody in the aorta, which is the main branch that runs down your body, that the blood would skirt out 21 feet, which is quite a bit of distance. There's a lot of pressure behind that. Gear pumps are another one, but bicycle pumps. I'm assuming most people are familiar with bicycle pumps. How does a bicycle pump work? You pull the plunger up, that fills all the chamber with air, and you push it down. It pushes all the air outside of the chamber. So all of these kind of pumps are a static effect, a geometric changing effect. But then we also have the dynamic pumps. Also called momentum pumps, that use momentum effects to move fluid through a system. And specifically, one of the ones that we're going to mostly focus on is rotary pumps or rotary dynamic pumps. And so these are the classification of momentum pumps that uses a rotational energy to add momentum to the system. So if we look at our dynamic pumps in the rotary dynamic category, we have centrifugal, which is a radial exit flow pump, which we'll spend most of our time on. And that's fluid comes in, it spins around, and it exits radially. We have an axial flow pump. Axial flow pumps, the fluid comes in one direction and leaves in the same direction. And then we have the mixed flow pump, which is the classification between the two of them. But we also do have a bunch of specially designed momentum pumps. The jet pump or the ejector pump is one of them. If you have a basement that's below grade, you may have one of these in your bathroom, where when the tank fills up and collects, it goes boom, and it just, with one big burst, sends all the fluid down the pipe. If you do have a liquid metal, you can use an electromagnetic pump, which is awesome. It's really cool to see. And it's basically just a bunch of magnets that push and pull the fluid through the system. And if you're doing any bio work, you can have a fluid actuated pump. Basically, you line up a bunch of cells with little flagellas sticking out and waving. And I just realized that as I have my hand out and wave, as I usually give this lecture in real life, that none of you can see it because I don't have the camera on. But so the little flagella, the little tails in the cells go up and down, which causes the fluid to move through the system. Now, for this class, we're going to look at those rotary dynamic pumps and look at the centrifugal, the axial flow, the mixed flow pump. Mostly focusing on this guy right here.